uh, that's a segue into what is this magical technology, and obviously how does it work that solves that problem, right? So to understand how blockchain works, you kind of have to think about things a little bit differently now, because now we're functioning in the digital realm, and everything that we are looking at in that digital realm, we have to look at through the lens of the technologies that work, and we have to classify everything now as an asset. So an email, a photo, a Word document, a spreadsheet, an application, anything that exists in electronic or digital form has to now be classified as an asset, because now what we're literally doing every day with these things is we're exchanging them. And in exchanging them, there's a value associated with them. So when you exchange emails, there's value in the email, right? When you exchange a photo, when you exchange music, when you exchange Word documents, there's, and you don't see it, but there's an intrinsic value in that exchange. So now we have to kind of get into the mindset of, look, everything that we interact with in the digital space is a digital asset, right? And based on that, we have to now think about a new way of treating with those things. So blockchain, by definition, is what's called a very secure, distributed, immutable ledger. Now, immutable means once a transaction is written to that ledger, it cannot be changed ever, right? And it keeps track of all transactions involving digital assets, right? And these transactions occur between, two individuals or groups of individuals. And in doing so, it keeps a track of every single transaction that has ever occurred. And it does so ensuring that double spend does not happen. And it also does so without the need for a middleman, which is typically called a central certifying authority. In the fiat system, that's the bank, whether it be the central bank or commercial bank, right? Now, what that does is it literally makes these transactions hyper efficient and very fast, right? Or comparatively fast. So this is in essence what blockchain is. It is a ledger. It is a very special ledger. It's distributed. It's a ledger that once information is written to it, can't change it. But the second part, which is being distributed, that is also very important. Being distributed, it means that the information that is stored in that ledger is not stored in one place or on one machine. It is stored on what's called a peer-to-peer distributed network. So a copy of that ledger always exists on multiple devices. And this is very important because it exists on multiple locations, right? That is what ensures that the level of fraudulent activity that could occur if it was only stored in one place doesn't happen. How does it do that? So explain that, we kind of have to explain what distributed ledger technology is. And what it really is, it's like I said, it's like think about it as like a spreadsheet that exists on multiple machines, hundreds, thousands. And whenever a change is made in one place in that ledger, that change is communicated to every machine that has a copy of that spreadsheet. All right. And whenever that change is made, everybody that has a copy of that ledger has to agree to the change. And once everybody agrees to or validates the change, then that addition to that ledger now becomes a block that is written to that chain of transactions or changes that has occurred. And that is how, so if you think about a very, very big spreadsheet of information, and, perhaps you have 10 different people making changes. What you always want to have is one version or a single version of the truth as it relates to that spreadsheet that everybody has. So sometimes, you're at, depending on environments that you work in, you may have a person in one agency or division or department working on a spreadsheet, and they save that spreadsheet, and another person in another department is working on the same spreadsheet and they save it, but they never get the changes from person in the other department. And what you start having is a huge variance in the information in the spreadsheet. Well, when you do distributed ledgers, all the changes are seen by everybody, and for changes to be made, everybody has to agree. That is generally how blockchain technology works, right? Generally how it works. And this is the most simple way of explaining how blockchain technology works. I'm gonna peel away another layer of the onion for you on that. So how does it actually do this, ensuring that everybody gets the same information, and then how does everybody agree to that? Well, what has to happen is all of the peers on this network that makes up this ledger, all right, this sophisticated spreadsheet, they exist in different locations, and there are a lot of them. And what they have to do is there has to be a process by which, when a change is made, everybody is notified, and then everybody comes to what is called a consensus, right? And that is now where it starts to get very technical as to how do you come to a consensus. The important thing here is that decision is void of human interaction, because that consensus is handled entirely by the machines that make up that network. All right. So typically you have a whole bunch of machines with their own copy of this ledger, and anytime somebody makes a change or there's a transaction that goes through, and you'll notice I'm going over this more than once because this is the crux of how blockchain works. I'm beating it in, right? And as long as everybody comes to a consensus about the change that is made, then the transaction is approved and a block is created, and that block is added to a chain of blocks that represents all the transactions in that ledger. All right. So one thing I want to point out, and this will become evident because it's a question that I was asked to answer in this session about central bank digital currencies and why they're not using blockchain and so on. One of the things that is very important to understand is that all blockchain technologies are based on distributed ledgers, right? But not all distributed ledgers are blockchains, right? So you can have distributed ledgers or distributed spreadsheets, right, all over the place on different machines. But if they're not synchronized and synchronized in a very particular way to ensure that no one version of that spreadsheet takes precedence over the other, everybody has to agree on it. If you don't have that, then it's really not a blockchain-based platform. So blockchains are a very, very specific type of distributed ledger, but you can have distributed ledgers of all different types out there, and they do exist, right? Blockchains are just a very special type of distributed ledger technology. All right. So let me get into a little bit more about how it works. All right. So mention that somebody makes a change in the ledger, and everybody has to agree. All the peers on the network have to agree, and once they agree, then the change is validated and a block is created and added to this chain. That's what I'm representing here in this diagram. So think about a transaction, right? Which is what a change amounts to. But now let's move back now and say any sort of transaction that could occur in the digital space, right? So one person says, look, I want to make a particular transaction happen. And that person, through whatever means, says, I want to, let's say, buy something, buy an item. And what happens is when they make the request to buy the item goes out into this huge network of peers. All of these peers have their own copy of the blockchain ledger. And that request goes out. And everybody looks at the request and compares it with everybody else and says, do you see this request? And everybody says, yeah, we see that request. Is it valid? And everybody, checks to make sure that it is valid. And they say, yes, it is valid. And the way they do that is it uses this very intricate consensus algorithm. I'm going to explain that right after this. And once everybody comes to an agreement, they say, look, this transaction is valid. And they say, thank you very much. We're going to create a block. And that block represents a valid transaction. And I'm going to add that block to the transaction that occurred before. And they're tied together, right, in a very secure and complicated way called cryptography. And once that block is created and added to the previous transaction, the transaction is complete and the chain is created. And every time a new transaction occurs, a new block is created and added to the block before it, and it creates a chain, hence the name blockchain. And, and once that happens, you have a very complex list of transactions. And because each transaction is dependent on the one before it, it's linked. So transactions are linked in this chain, which is why it is so secure and why it is so trusted, right? Which is why it is called immutable, because you can't change a transaction that is in the chain without destroying the entire chain, right? So once a transaction is validated and a block is created and added to the chain, the transaction is complete, and there is an immutable record of that transaction, which is tied to the transaction before it and which will be tied to the transaction after it. The longer the chain gets, is the more secure it becomes, because the harder it is to try to change a block that is in, an early part of the transaction linkage, right? So that's typically how blockchains work. Request for a transaction is made. The network notices a transaction. They validate it, create a block, add the block to the chain. Transaction is complete. All right. So let's peel away another layer of that onion. How does the block get created? Now, I'm not gonna talk too much about this because this is getting really technical now. But in every blockchain, you have what's called a genesis block, block 0. That's the very first block in a blockchain, and every block after that is tied to the genesis block or the block before it. Right? And I think in this diagram, I'm trying to represent how that works. And one thing that you have to understand with blockchain is only one block can be added at a time, and every block is unique, and it is unique in such a way that no two blocks can be duplicated, and they always follow a specific sequence, and that sequence is borne out in what is called a cryptographic hash. So if you look at this slide here and you see these weird looking numbers, you'll notice that every block has two hashes: the hash of the block before it and the hash of its block. And because of that, and these numbers are extremely long. So the numbers that you're seeing here are relatively short, but in typical blockchains, these numbers are very long. And because of how they're created, it makes blockchains extremely secure, but it makes them extremely immutable, right? Which means changes can't be made once blocks are written. And this is the big thing behind blockchain. It's security, its immutability, and its distributed nature. So the next thing that I just wanted to touch on is that decision-making thing that occurs in the network. So when the transaction goes to the network, and all these machines are located all over the place, globally in some instances, because the Bitcoin blockchain network is a global one, and there are thousands of machines that participate in that network. How do all of them communicate to make the decision to ensure that a Bitcoin transaction or a transaction for any cryptocurrency happens? They use what's called a consensus algorithm. There are many of them. I'm not going to get into the specifics, but there are a number of different consensus algorithms. It varies depending on the blockchain platform. You have what's called proof of work, proof of stake, BFT, which is the granddaddy of them all, proof of elapsed time. These are all different methods by which each type of blockchain network or platform comes to agreement about transactions. All right, not getting into the technical aspects of this, but what is important to know is that each type of, whether it be cryptocurrency or platform, uses a specific type of consensus algorithm to come to a decision about how transactions are validated and how blocks are then created and written. All right. I was going to touch on a couple of them, proof of work, primarily because proof of work is the consensus algorithm that's used in Bitcoin, in the Bitcoin blockchain network, primarily. And really the way it works is you have a whole bunch of machines, and they're given a mathematical challenge, and whoever solves that challenge, and the people who participate in that exercise are called miners. Whoever participates in that challenge, whenever they solve the mathematical problem, which is the consensus part that actually allows the block to be created, then they earn Bitcoin from that transaction exercise. And pretty much that is how blocks are created and how transactions are validated. Very confusing sometimes, but that's the underlying craziness that goes on, which is why the blockchain technology is so fascinating, because it is this kind of complex action that's happening in the background to ensure that transactions can be trusted when there is no middleman. All right. So if you are to remove people, remove middlemen, and have computers decide, there has to be a trustworthy way for that to happen, and that's what these consensus algorithms look to do. The other one that's there is proof of stake, and there are a whole bunch of different protocols that exist in the blockchain space that use these different algorithms to do what they do. You have Ethereum, which is very popular. That's a very popular blockchain protocol. Incidentally, Ethereum is also a cryptocurrency. You have Hyperledger, you have Quorum, you have Corda, you have Multichain. These are some of the more popular blockchain protocols that exist. And what you will find is that regardless of which one your platform runs on or your system uses, they generally conform to the same sort of operating principle, which is distributed ledger with a consensus algorithm that makes a decision on validating a transaction. And that's generally how all of them work.